See here, object move here at a certain distance, okay, from the surface of the earth. The kinetic energy is equal to half into mv square, and potential energy is equal to minus g mm upon r, because here object move from a certain height, okay, and when object move from the certain height, it form here kinetic energy, that is half mv square, and thereafter a certain velocity decreases here and stop here at some height, and again it will come back, so it form potential energy here, so that is minus g mm upon r. Okay, therefore total energy is equals to total energy, that is E1 is equals to kinetic energy, that is half mv square plus minus g mm upon r, half mv square minus g mm upon r. It's clear. And object covered here infinite distance, suppose object covered from an infinite distance, or object move away from the gravitational field, okay, the object covered in infinite distance, so what will happen? Their kinetic energy is zero. Kinetic energy is here zero. Why? Because their object moves to or covered here infinite distance, they're not having velocity, okay, stop their object, stay their object, therefore kinetic energy is zero, and potential energy is there. Potential energy is there minus g m upon infinity, because distance is there infinity. That means here, if the infinity is distance is infinity, that means here potential energy also zero. It's okay, because there infinite distance, that means here potential energy is here zero, and total energy is also here zero. It's okay. Now, according to law of conservation, that is E1 is equals to E2. We know that energy does not over. Okay, energy does not over. It will go from one form to another form. That is, kinetic energy is converted into potential energy, and potential energy is converted into kinetic energy. It's okay. Therefore, E1 is equal to E2. But E1 is here half mv square. Okay, it is cap velocity. Velocity is cap. mv square ESC minus g m upon r. It's clear. Is equal to E2 is here 0. Put here 0. Thereafter g negative minus g mm upon r, take here another side, it will go to positive. That means here half mv square is equal to g m upon r. It's okay. Thereafter this m and 2 take to another side, so what will happen? V square ESC escape velocity square is equals to g 2g m upon r into m. This m and m get cancelled. Now right here v square is equals to 2g m upon r. 2g m upon r. But now, student, we know that here small g equals to gm upon r square. Small g is equals to small g, that is acceleration due to gravity, so gm upon r square. Is right? R square. Put here v square equals to 2gm into r upon r square, because multiply them here, numerator and denominator multiplied by r, it will make here r square and also r. It's clear. Now v square equals to 2gr, because 2gm r square is a small g, therefore it will make here 2gr. It's clear. V square equals to 2gr. It's okay. Therefore V equals to what will happen here? Taking here square root. Therefore, V equals to under root 2gr. V means here velocity, escape velocity equals to under root 2gr. It is a mathematical expression of a escape velocity. It's clear? Now, take here solve example. Calculate the escape velocity on the surface of the moon given the mass and radius of the moon to be 7.34 into 10 raised to 22 kg and 1.74 10 raised to 6 meter per respectively. Student, listen here. There are given, find here, calculate the escape velocity. Okay, the surface of the moon, and mass is given here 7.34 into 10 raised to 22 kg, and distance is given here 1.74 into 10 to 6 respectively. Okay, so now we know that here escape velocity equals to under root 2gm or 2gr, right? But we can take here any formula. So put here value 2gmr. Suppose we have to take in here under root 2gmr. So put here value. G is here constant value 6.6 into 7 into 10 raised to minus 11. 2 into 6.67 into 10 raised to minus 11, and m is given here 7.34 into 10 raised to 22, and r is given here 1.74 into 10 raised to 6. Okay, thereafter solve them, and after solving we will get here answer 2.37 kilometers per second. Okay, students, solve this example. Okay, and if you have any doubt, you ask me. Understood? I'll stop here.